Welcome back. In today's lesson, we're going to start solving. Solving is something you've been doing in middle school, so hopefully a lot of this is review, but I'm going to start off pretty slow and take it one step at a time. So for our first foray into solving, we're just going to solve 1- and 2-step equations with variables on either side. So the first thing I want to make sure we know is what a solution is. So a solution is a value of a variable or unknown that makes an equation true. So there are a couple ways we can solve equations, and I'm going to show you the way that you've drawn the line, added and subtracted both sides, but I first want to be able to help you understand logically what's going on in those types of examples. So solving logically means what is making this equation true in my mind? How can I look at this equation and see what it means and try and make sense of it? So for example 1, the direction will just say solve. But I want to show you what you should sort of be thinking in your head. So if I'm looking at x plus 5 equals 7, I'm asking myself, what is x? What is it? I don't know what it is, but I do know that what plus 5 gives me 7. So what is that? What plus 5 gives you 7? And that would be 2. If I were to fill in the blank, it would be 2 plus 5 equals 7. It's a pretty simple example, but 2 would be the solution here. That's the missing value that makes this equation true. 2 plus 5 equals 7. For letter B, we're asking ourselves 10 minus x equals 1. We're saying what subtracted from 10 gives me 1. So if I want to take something away from 10 and I get 1, it's going to be a 9 because 10 minus 9 equals 1. So my answer here is 9. So that's solving logically, is looking at an equation, asking yourself, what makes sense here? What makes this equation true where I get the same thing on both sides? Okay. The other way you can sort of simplify this is saying, well, 2 plus 5 is 7, and 7 equals 7. 10 minus 9 is 1, 1 equals 1, it's true. So that's solving logically. That's the basic fundamental of solving. Now, what we've learned in middle school is how to solve by undoing. Okay, and what I mean by this is looking at what the equation is really saying and then undoing that to get your answer. And this is going to work for more complicated equations where you can't just look at it and logically think it through very easily. We need some sort of process. So these are the same two equations as in example 1, but I'm going to show you what I mean by undoing. So when I look at this equation right here, I'm thinking, what's happening to x? Well, we're adding 5 to it. And then if I want to undo that, so to undo the 5, I'm going to subtract it because the opposite of addition is subtraction, and we're going to be thinking opposites here. So we're going to undo it by subtracting 5. So, if I do something on one side, I have to do on the other. So I like drawing a line down the equal sign. This will help you tremendously. I recommend all of you draw this line to separate one side of the equals from the other side of the equals. So if I'm adding 5 initially, to undo, I'm going to subtract the 5. And whatever I do on one side, I have to do on the other. The 5 minus 5 equals 0. So I like to cross that out, and I'm going to bring down my x. 7 minus 5 is 2, and notice that I get 2. Isn't that true for what I got up here? I got the 2 up here, and I got the 2 down here. So both logically it works, and my solving by undoing works as well. So I hope this sort of shows you that this process is effective. Letter B is a little bit is harder to solve by undoing because we've got 2 steps going on. We have this negative 1 here. I'm going to draw in the invisible 1. We're always drawing in invisible 1s, and we have a minus sign. So the first thing that's happening here is that we're multiplying by negative 1. And then this 10 here doesn't have anything in front, so that's sort of like an invisible plus sign. So we're multiplying by negative 1, and then we're adding 10. So then to undo this, we're going to do the opposite. We're going to subtract the 10, and we're going to divide by negative 1. So we're doing the opposite way from how it started. So again, I'm going to draw my line. And my first step is to subtract 10. I like writing it underneath the number and writing it underneath the other number on the other side. This helps keep your work really organized. Draw a line here to show that you are adding these things together. So 10 minus 10 cancels out to 0, so they're gone. And then 1 minus 10 is negative 9. When you carry this down, you've got to remember that the negative 1 carries down with it, that invisible 1. That's going to help you because now you can see that your next step is to divide by that negative 1. Like over here. So we've subtracted the 10 and now we're dividing by negative 1 on both sides. These cancel out because, I'm going to write it over here, because negative 1 divided by negative 1 equals 1. And so that just cancels out to 1, which is what we want. We want those two things on top and bottom to cancel out to 1, so that leaves me with x by itself. We want x to be alone on one side because we want to find out what x equals. Well, what is negative 9 divided by negative 1? Positive 9. So notice that that is the same answer as we got up at the top. We just did it in a different way. And this way of solving is the way that will work on every single problem you see today. Okay. Let's look at something a little more complicated here. Okay. And I'll work on it without having to write down the undoing. We're just going to talk about opposite operations step by step. So draw your line. Do the equal sign, give yourself that nice separation. I'm going to do my minus 3 first on both sides. I always save my division for last, every time. The 3's cancel out, and I'm left with, and if you want to draw an arrow to bring that 2x down, you can do that because it just gets brought down past the line. Negative 17 minus 3 is negative 20. And then I want to get rid of that 2. And when I've got 2 and x mushed together, that's like an invisible multiplication sign. Opposite of multiplication is division. And I show that with a fraction bar. So on the other side, I'm also going to divide by 2. The 2's cancel out, and I'm left with x equals negative 10. And you can use your calculators to do these calculations. Okay, I like negative 17 minus 3. I knew that's negative 20, but if you're not sure, you can use your calculator. Negative 17 minus 3, and you get that negative 20. So feel free to use your calculator to check. It would be so unfortunate for you to make a mistake because you did your arithmetic wrong. It happens often where students really want to do math in their head, but then a simple mistake happens and the whole problem is wrong. And we don't want that to happen. So I recommend using your calculator as much as possible to even just double check your mental math. Letter B is a bit trickier because I've got x on the right side. We really want x to be on the left side. It's the proper professional way to write our answers, so we're eventually going to get it on the left side. But for now, let's focus on our addition and subtraction and getting rid of this 19. So 19 is positive by default. It doesn't have a negative in front, so to undo it, I'm going to do minus 19 on both sides. Draw my line. The 19's cancel out. Negative 5 minus 19 is negative 24. Bring down that negative 4x. To get the x alone, I'm going to divide both sides by negative 4 to undo that multiplication. They cancel out, and I get x equals negative 24 divided by negative 4 is positive 6. I don't want my variable on the right side, so all I need to do is switch it and put x equals 6. means the same thing. 6 equals x is the same thing as x equals 6, but we want our answer to have that variable on the left. Okay, now I want you to try the next example. So like in the last lesson, you're going to pause the video, try to do this problem on your own and see if you get the correct answer. So go ahead and pause now, try this problem on your own and see what you get. So for this example, you should have gotten n equals -1. Okay, I'm going to go ahead and walk through this one as well because there was something tricky in it that you may not have seen. Oh no, sorry, that's not this example, that's a later example. So you should have gotten n equals -1. There are times I'll show you the steps for the U-tries and there are times I will not. So when you're coming up to ask for mastery and you don't have the U-tries done with your work shown, I will make you go back and do those U-tries. So please be sure you're doing them and showing your work. What happens if we have variables on both sides? Okay, on both sides. That's going to happen quite frequently, and we need to be able to figure out how to do those problems. So the first step is always the same. Draw your line down the middle, as long as you want it to be. So I've got -3x minus 15 equals 1 minus 5x. I want all my variables on the same side. Preferably the left. And if I want my variable on the left in this first example, I have to undo that minus 5x by adding 5x. And that's going to put it on the left side for me because it's going to cancel that out. Now, if I add 5x on the right, I've got to add 5x on the left, and I'm going to write it underneath its like term. So I'm going to write it underneath the -3x. That's going to help me do my addition. So -3 plus 5x is 2x. I'm going to carry down that -15, and what's left over on the right is a +1. Now I'm going to solve it like I solved the other problems we just did in example 3. So I'm going to undo that 15 by adding 15. I'm going to do that to both sides. Draw my line. The 15s cancel out, and I get 2x equals 16. And the last step is to undo the 2x by division, and I get x equals 8. Okay. Letter B has a step we have to do first before we start adding and subtracting things to both sides. You'll notice that on either side of this equation, you've got like terms. What I mean by that is on the left side, I have -16, +3, and +4 that are all like terms. So I'm going to ignore the right side for now. And on the left side, I'm just going to combine like terms. The 2x has nothing with it, so I'm just going to bring him down. So he's done. I like to cross things off when I'm done with them. It helps me keep track of what I used and what I haven't used. Then I'm going to add these whole numbers together, these constants. -16 plus 3 plus 4 gives me -9. And you can use your calculator to double check that mental math. On the right side, I also have like terms. I have a 6x and a 4x. I need to combine those first. So 6x and 4x gives me 10x. And then I can just bring that +7 down because he didn't have anything to add to it or combine with it. Now I can go ahead and start doing what I did here with what I did in the previous example. So I'm going to go ahead and minus 10x on both sides to get those x's on the left. These cancel out. And on the left side, +2 minus 10 is -8x. Bring down that -9. Bring down that +7. Then I'm going to go ahead and undo the 9 by adding it to both sides. The 9's cancel out, and I get -8x equals 16. Last step is to divide by that -8, and I get x equals -2. Okay. The next problem is a little tricky, but I really want you to try it on your own. Okay, so go ahead and pause the video, try and see if you've got like terms on one or both sides, combine those first, and then go ahead and solve by undoing. So go ahead and pause now and give it a try. So for this problem, you should get x equals 7. Now, I'm going to walk through this one because there is something really tricky that you may not have seen to do. You may have gotten x equals just regular 7, positive 7. So let's take a look at how we do this problem. So on the left side, I have no like terms. So I can just go ahead and rewrite the left side, 2x plus 13. But on the right side, I've got this negative 2x and positive 5x. The 6 gets brought down. Let me draw that a little nicer. And then negative 2 plus 5x is going to give me a positive 3x. So that should have been your first step. Then we're going to subtract this 3x on both sides, and here where it gets a little tricky. These cancel. The 6 keeps getting brought down. And on the... Oh, hold on. I'm going to draw my line here to help. So the 6 gets brought down, the 3 and the negative 3 cancel, and on the left side, the 13 gets brought down. This 2 minus 3 gives me a negative invisible 1x. That negative 1 is really important for getting the correct answer. You'll see why. When I subtract the 13 now on both sides to get x alone, they cancel, bring down that negative 1x. 6 minus 13 is going to be negative 7. So how am I getting positive 7 here? Well, I've got to get rid of this negative 1. Okay, that negative 1 right there. So I need to divide by that negative 1. I can't have a negative in front of the x in my final answer. So the negative 1's cancel out, and negative 7 divided by negative 1 is positive 7. Negative divided by negative is a positive. So that's how I got that 7 for this U try. Okay? So this is solving basic equations. These are what your practice problems will look like. Again, I think that a lot of you will have questions, and that's okay. That's what I'm here for. Please, I need you to show your work in this learning target. The answer key will just have the answers in there for you. It will not have the work, and I will not let you take mastery until that work is shown. So please make sure you're showing work. And if you need help, please come ask. Good luck.